Hello and welcome to today's revision session on A-Level Physics Paper 2. So if we are successful and we learn in today's revision session, we should be able to answer examination questions on AQA A-Level Physics Paper 2. Now this means that in this particular revision session we'll look at answering these A-Level Physics examination style questions, in particular multiple choice style questions. We'll then assess your understanding on A-Level Physics and then finally understand what topics you need to improve upon for A-Level Physics. So how do you carry out this particular revision session? Well, when completing your work in this revision session, divide your piece of paper into two sections. Make the section on the left hand side larger than the right hand side. Now in the left hand side section, write down your working out and answers to the question in the revision session. Now when you do this, make sure you write it out in full sentences and show your working out. Whilst in the right hand side in this section, write down any pieces of information which you find useful or any hints and tips on answering questions from this revision session. And at the end of this revision session, write up these notes into a revision sheet for you to use independently. Now, how should you carry out revision for AQA A-Level Physics? So the first step I would do is learn the key facts, learn the knowledge. So this could involve using your revision guide, your class workbook, your student prep notes, your textbook to learn the key ideas of the course. And you might want to make mind maps or write out notes yourself to do this. The second step is to test yourself. So use e-learning platforms like Caboodle, like Seneca, like your own student knowledge checkers to quickly test your own knowledge, and you may wish to do this from your own cue cards. Then finally, step 3 is practice examination style questions. So use exam prep books, homework books, supervised study books, workbooks to answer examination questions and mark your own work, and you may wish to download your own past papers to do this. So the 3 steps of learning the key facts, testing yourself, and then practicing examination questions will allow you to adequately prepare for your AQA A-Level Physics examination. So let's have a look at a few questions, starting off with thermal physics. Now in this revision session we're only going to focus on multiple choice questions. So let's have a look at the following question. Two containers X and Y each contain an ideal gas at the same pressure. The volume of X is twice the volume of Y. The temperature of the gas in X is 150 Kelvin. The temperature of the gas in Y is 300 Kelvin. The number of molecules in X is N. What is the number of molecules in Y? So pause the video now, then unpause the video when you want to go through your answer. Right, so how would you answer this question? Well, we know that for an ideal gas, PV is equal to NKT. Now, it's important to say that we can equate these equations for each gas via the K because K is a constant, so it's the same for both gases. So we therefore can say P1V1 over N1T1 is equal to P2V2 over N2T2. This is a good trick you can do with all the ideal gas equations when they have constants in them. Now, you'll notice they both have the same pressure, so pressure cancels through because it's the same for both gases, whilst we can pop in our numbers. So we know that the pressure of X is twice that of Y, so we can say 2 for P1 and 1 for P2. We know the temperature of X is 150, whilst the temperature of Y is 300. So we can pop those in the equations. We can then rearrange it to make the number of molecules for Y, which I've denoted as N2 in this particular equation as the subject, work our numbers through, and we get our answer to be N over 4, which is the answer for A. Next question. A student wants to do an experiment to verify Boyle's law. What quantities must be measured and which quantity must be kept constant? So pause the video now, then unpause the video when you want to go through your answer. Right. So it's very important you know for your ideal gases, for your different laws, and what you've got to keep constant and what you've got to change if you want to verify these laws. Now, Boyle's law is the link between pressure and volume. So this means you're going to have to measure both the pressure and the volume. But there are always 3 quantities that can affect an outcome in an ideal gas: pressure, volume, and temperature. So this means if we don't want to consider temperature, we want it to be isothermal, we need to keep temperature the constant to ensure valid results. So the answer is B. Next question. Brownian motion demonstrates what? So pause the video now, then unpause the video when you want to go through your answer. Right, so you need to know what Brownian motion is and why it's so important. Now, Brownian motion is something which indicates that gases are made out of randomly moving particles which will collide with surfaces and objects, which will give them a momentum because they are colliding with objects at a particular velocity. So that indicates what Brownian motion demonstrates. That is a particular fact you've just got to recall. Next question. The molecular mass of carbon dioxide is 44. How many molecules are in 2.4 kilograms of carbon dioxide? So pause the video now, then unpause the video when you want to go through your answers. Right, so how do you answer this question? Well, you look to see what information you're given. You're given the molecular mass, or MR, and you're given the mass of the carbon dioxide. So we know that the number of moles is equal to the mass in grams divided by the molecular mass, or the MR. So we'd say 2,400 divided by 44, because that is what 2.4 kilograms is in grams. So it equals 54.5. Now we know 1 mole contains 6.023 times 10 to the 23 molecules. That's Avogadro's constant. That's a fact you've got to recall. So therefore the number of molecules is equal to the number of moles times by the number of molecules in 1 mole. So we get 3.3 times 10 to the 25. So our answer is D. Let's now have a look at some questions to do with gravitational fields. So let's look at our first question. The diagrams show two field patterns of field lines X and Y around a particle. Which row is correct when the particle is a proton? So pause the video now, then unpause the video when you want to go through your answer. Right, so it's important to note that electrical fields have field lines that show the direction a positive charge would take. Now another positive charge would repel the proton. So as a result, the electrical fields would have to be X, because it is repelling it, so the lines are pointing away from it. Now the other thing to note is that in a gravitational field, the field lines show the direction a point charge would take in that situation, point mass, would take in that situation. So because the gravitational field lines show the direction a positive mass would take, that would be the Y, because the lines are pointing inwards, because it's an attractive force. So because the electrical field is repulsive in this situation for a positive charge and a proton, it will be X for the electrical field, but because the gravitational force is attractive and is always attractive, it will be Y. So the answer would be C. Next question. A satellite moves from a high orbit into a lower orbit. Which row describes the changes to the satellite's potential energy and kinetic energy? So pause the video now, then unpause the video when you want to go through your answer. Right, so you've got to be aware that the entire energy store of an orbiting body is the kinetic energy plus the potential energy. Now it's also important to note that as the total energy in an orbiting body remains constant, energy can only transfer between the two stores. So when you move into a lower orbit, you are closer to the center of mass of the system, so the potential energy of the system will decrease. But this would mean that the kinetic energy of the system increases to ensure the conservation of energy, which makes sense because the closer the object is to the center of mass, the faster the object moves. So the answer would be C. Next question. The diagram shows 2 point masses, each of mass m, separated by distance 2r. What is the value of the gravitational field strength at the midpoint P between the two masses? So pause the video now, then unpause the video when you want to go through your answers. Right, so how would you answer this question? Well, what you've got to do is, because gravitational field strength is a vector quantity, what we can say is we can equate the two values, one from the mass on the left and one from the mass on the right, and see what our overall value is, what's our resultant answer. So as we know, the gravitational field strength is gm over r squared. Now if we have it at the dead center at P, we know that the values of mass for both of the masses are the same, because it tells you that they're each of mass m, and their value of r is the same because they are each the same distance from P, r. They will produce the same value of gravitational field strength because g is a constant. So we can therefore say that the two masses will produce an equal gravitational field strength, but they're acting in opposite directions because gravitational field strength is always attractive. So the mass on the left would attract an object to the left, a mass on the right would attract an object to the right. So the two would cancel through, so therefore you get your overall value to equal 0. The answer is D. Let's now have a look at a few questions on electrical fields. So, the force between 2 point charges is F when they are separated by a distance r. If the separation is increased to 3r, what is the force between the charges? So pause the video now, then unpause the video when you want to go through the answer. Right, so how would you answer this question? Well, it's very important that you've got to write out what the equation is between these 2 point charges. It's the Coulomb equation. It's Coulomb's law. So we can say F is equal to Q1 Q2 over 4 pi epsilon 0 r squared. And we'll just say 4 pi epsilon 0 is equal to K in this instance. So as a result, R is going to become 3R because the separation has increased. So therefore we can write it into the equation that F is equal to Q1 Q2 3KR squared. So K 3R squared. Now this means because we are squaring the 3, because it's a 3R squared, this means that it's going to be over 9 because 3 squared equals 9. So therefore the force becomes F over 9. So the answer is D. Next question. 2-point charges of magnitude Q are separated by a distance r. The electrostatic force experienced by each charge is F. What force will be experienced by each of the 2-point charges of magnitude 3Q separated by a distance of 2r? So pause the video now, then unpause the video when you want to go through your answer. Right, so how would you look at this question again? Well, again, it is about the force exerted on each of the 2-point charges. So we've got to use that Coulomb law's equation again, that Coulomb force equation. So F is equal to Q1 Q2 over 4 pi epsilon squared, epsilon r squared. So we can say Q1 Q2 over K r squared. Now again, we look at how it's changed. So we're now separated by a distance of 2r, so therefore, and each q becomes 3q because they've now had their magnitude of 3q, so we can therefore say 3q1 3q2 over k 2r squared. We can then multiply 3 times by 3 at the top, so it's going to be 3 times by 3, which is 9 divided by 2 squared, which is 4 because it's r squared, so it's 2r squared. So therefore F becomes 9F over 4. The answer is C. Next question. A small sphere of mass m carrying a charge q is suspended from a thread and placed in a horizontal electrical field of strength E. When the sphere comes to rest, the thread makes an angle theta with the vertical and the tension in it is T as shown in the diagram. W is the weight of the sphere and F is the electrical force acting on it. Under these conditions, which of the following equations is incorrect? So pause the video now, then unpause the video when you want to go through your answer. Well, again, it's very, very important that you can resolve forces into different components, onto horizontal and vertical. Now, you'll notice in this situation, let's have a look at what the vertical component of the forces are going to be. Well, we can say that we've got T cos theta because all of T is not in the vertical. We've done our right-angled triangle and resolved it and worked out that the vertical component of T is T cos theta, which equals mg, the weight. Now, the horizontal component is equal to F equals T sine theta. So what we can also do now is we know T cos theta equals mg and T sine theta equals Fe, we can divide the two and say T sine theta over T cos theta is equal to Fe over mg. So therefore T sine theta over T cos theta becomes tan theta. The two T's cancel through and sine over cos equals tan. So that equals Fe over mg, and we know the electrical force is Eq, so mg is equal to Eq tan theta. So as a result, what is the only one that will be incorrect? Well, the only one that will be incorrect in this situation will be the answer of D. Right, so next question. The scale diagram shows two positively charged spheres X and Y. The charge of X is 5 times the charge of Y. The electrical field strength of P due to X is EX, and the electrical field strength of P due to Y is EY. So what's true for EX and EY? So pause the video now, then unpause the video when you want to go through the answers. Right, so what again you've got to do is work out the size of the electrical field strength due to X at P and due to Y at P, and then look to see how they link to each other. So we can tell straight away that the distance from Y to P is square root 10. We can do that by taking our measurements and using the idea of triangles, whilst the distance from X to P is 5. Once again, we can do this by taking our measurements and working it through. Now, at this point, we can say EX is going to be equal to Q over 4 pi epsilon 0 or K r squared. So in this case it's going to be 5Q. We can work that through 5QY over 5 squared. So therefore K is equal to if K is equal to QY over 5, whilst EY is therefore going to be equal to QY over 10. So therefore it's going to equal QY over 10. Now why have we used X as 5QY? Because it says in the question that charge of X is 5 times the charge of Y. So we can just pop that in like that. So therefore we can equate the two and say EX over EY is equal to 1 over 5 divided by 1 over 10, because KQY is a constant in both, so we can cancel them through. So therefore when we work that through, we do 1 over 5 divided by 1 over 10, we can say EX is equal to 2EY. So our answer is A. Next question. A positron is at a point in a uniform electrical field where the electrical field strength is 2.4 kilovolts per meter. The acceleration of the positron is what? So pause the video now, then unpause the video when you want to go through your answer. Right, so how would you answer this question? Well, it's asking about acceleration. Now, the first thing we need to know is that the electrical field strength is equal to force over charge. So therefore, force is equal to the electrical field strength times by Q. Now, you've been given the electrical field strength, which we can say is 2.4 times 10 to the 3, because we've got rid of that kilovolts, times by the charge of the positron, which is 1.6 times 10 to the minus 19. So we can work out what our force is. Now, we can say acceleration is force over mass. Now, again, remember, you can always use Newton's laws of motion, those equations of motion, in any electrical or gravitational or magnetic field scenario. It still follows Newton's laws. So therefore we can say our answer is 4.22 times 10 to the 14 meters per second squared. Now this will be in the same direction as the electrical field strength, because the electrical field always points in the direction a positive charge will take, and a positron has a positive charge. It is an antiparticle of an electron. So therefore the answer is D. Next question. The diagram shows two parallel conducting plates and a graph of the variation of potential between the plates. What is the magnitude of the electrical field strength between the plates? So pause the video now, then unpause the video when you want to go through your answers. Right, so how would you answer this question? Well, it's important that you know what the different graphs in fields show us. Now, the graph of V against R indicates to us the electrical field strength, as the gradient of the line is the electrical field strength. So if we do our gradient, it is 800 divided by 0.02, because we want to work in meters. That gives us an answer of 40,000 newtons per coulomb, which is the answer for D. We're now going to look at a few questions regarding capacitance. So, a capacitor of capacitance 9 nanofarads has plates with overlapping areas of 18 centimeters cubed separated by a dielectric of thickness 0.15 millimeters. What is the relative permittivity of the dielectric? So pause the video now, then unpause the video when you want to go through the answers. Right, so it's important that you can use the parallel plate capacitors equation in this situation. So we say capacitance is equal to A E0 ER over D. So we then got to rearrange it to make ER the subject, and then we pop in our numbers. So remember, we convert 9 nanofarads into farads by saying it's 9 times 10 to the minus 9. We convert our thickness from millimeters into meters by doing 0.15 times 10 to the minus 3. We convert our centimeters cubed into meters cubed by doing 18 times by 10 to the minus 6, which will work through. Remember, we're going from centimeters cubed to meters cubed, and then we multiply by E0. We work that all through, and we get our answer out to be 8.5 times 10 to the 1. So our answer is A. Next question. The graph shows how the charge on a capacitor varies with the potential difference across the capacitor. What is the additional energy stored by the capacitor when the potential difference increases from 200 volts to 400 volts? So pause the video now, then unpause the video when you want to go through the answer. Right, so what you've got to do here is understand how you can work out the energy stored by a capacitor. So we know that energy is equal to a half Q times by V. Again, why would you use this equation? Well, you've got Q in the question, you've got V in the question. So work out what it would be at 200 volts. So you go to 200 volts and see that the charge is going to be 2 times 10 to the minus 3, because it's 2 millicoulombs. So therefore you would convert into coulombs. So you get 0.2 joules. You then do the 400 volts. So go on 400 volts on the graph, and you see it's 4 times 10 to the minus 3 coulombs. So therefore, times that by 200 is 0.4 joules. So the answer is A, because the difference between the two, okay, is going to be 0.2 joules. Next question. The table shows data for two capacitors, P and Q. Each capacitor contains a dielectric material. What is the energy stored by capacitor Q? So let's pause the video now, then unpause the video when you want to go through the answers. So, how would you answer this question? Well, again, you've got to use our parallel plate capacitor equation and say C is equal to A E0 ER over D. Now, for our new energy stored by our capacitor, we've got to add in these different terms. So we put 3A in instead of A, we put 2ER in instead of ER, and we put 1.5D instead of D in by looking at those particular values. So subbing those into our new equation, we work it all through and we see it's now 4. So therefore, the new capacitance is going to be 4C. Our new potential difference is 2V. It tells you that in the question. So because energy is equal to a half CV squared, it's going to be equal to a half times by 4C times by 2C squared. So therefore we equal 16E. So 16 times by the original E, which is 80, is equal to 1280 millijoules. The answer is D. Next, let's look at the next question. The graph shows the variation of charge Q on a capacitor with a potential difference V across it. Which row shows the significance of the gradient of the graph and the area between the line and the V axis? So pause the video now, then unpause the video when you want to go through your answers. Right, it's very, very important that you understand what the gradients of graphs show and what the area under the line shows. Now, as an approximation, what we can say is that the gradient of the graph is going to be y over x, whilst the area between the line and the v-axis is going to be the area. So therefore, in most cases, it's going to be y times by x, but in this case it's going to be a half y times by x because the area is a triangle, so it's a half base height. So what do we know? Well, we know C is equal to Q over V, so that's y over x, so that's going to be the gradient, whilst the energy stored is a half QV, which is going to be the area under the line, so therefore that will be our area. So the answer is D. Next question. A capacitor discharges through a 22 kilo ohm resistor and it takes 0.75 seconds for the potential difference across the capacitor to fall from 8 volts to 4 volts. So what's the capacitance of the capacitor? So pause the video now, then unpause the video when you want to go through your answer. Right, so you know that it has fallen from 8 volts to 4 volts, so therefore it is going to go to half of its value. So we can say that the time it takes to fall to half its value for a capacitor is equal to log 2 or 0.69 times by RC. So therefore C is going to equal to the time it takes to fall by half divided by log 2 or 0.69 times by R. Pop our numbers through into that. Remember, we're changing 22 kilo ohms into 22,000. Therefore we pop our numbers through and we get 49 times 10 to the minus 6 farads. The answer is B. Next question. A charged capacitor of capacitance 460 microfarads discharges through a fixed resistor. After 184 seconds, the capacitor has lost 75% of its initial charge. What is the resistance of the fixed resistor? So pause the video now, then unpause the video when you want to go through the answer. Right, so how can we answer this question? Well, we've got to use our discharge equation for the capacitor. So our discharge equation for the capacitor is equal to V equals V0 e to the power of t minus t divided by RC. So therefore we can rearrange and make R the subject. So if we take natural logs of both sides and rearrange the equation, we get the equation to be R, the resistance, is equal to minus T over log V over V0 times by C. So we can then pop our numbers in. Now again, the important thing is to read the detail in the question, because it has lost 75% of its initial charge. So therefore it only has 25% of the initial charge remaining. So what this means is we can now say that log V over V0 is equal to log 0.25 V0 over V0. The V0s cancel through, so it just becomes log 0.25. So we pop our numbers in and we get our answer to be 288539, which works through to be 2.9 times 10 to the 5 ohms. The answer is B. Let's now have a look at a few questions concerning magnetic fields. So, two coils L and M are placed next to each other as shown. There's an alternating current in coil L and an alternating potential difference across coil M. Which of the following changes will not increase the maximum potential difference across M? So pause the video now, then unpause the video when you want to go through your answer. So, how would you answer this question? So if the separation of the two coils increases, then the magnetic flux linkage between the two coils decreases because there's less overlap, and the magnetic flux linkage is the overlap or the linkage between the objects. So this would therefore lead to a smaller change in magnetic flux linkage. Now remember, it's a change in magnetic flux linkage that leads to this magnitude of the induced EMF. So a smaller change in magnetic flux linkage leads to a smaller induced potential difference. So therefore the answer is D. Next question. A closed horizontal conducting coil falls vertically through a horizontal magnetic field. The coil has a small resistance. Due to its movement through the magnetic field, the coil will experience what? So, pause the video now, then unpause the video when you want to go through your answers. So, how would you answer this question? Well, as the coil falls vertically, there's going to be a current induced in the coil because the coil is experiencing a change in magnetic flux linkage as it falls through that magnetic field. But it's going to be flowing in opposite directions and opposite sides of the coil, because you'll notice that as it's falling down, it's going to be cutting in a different way, so they'll be producing them in opposite directions. So as a result, this will mean that whilst there will be a induced current in one direction and an induced current in the other direction, and they'll both produce their own magnetic force, because when you have a current going through a conductor, it produces an magnetic force by electromagnetism. But because they're equal yet opposite, they will cancel each other out, so there's no resultant force and there's no resultant moment. So the answer is D. Next question. A current I is supplied by a coil rotating in a magnetic field of flux density B. The angle between the plane of the coil and the magnetic field is theta. Which graph represents the variation of I with theta? So pause the video now, then unpause the video when you want to go through your answer. So, how would you answer this type of question? Well, when the angle is 0, you're going to get the greatest change in magnetic flux linkage. So as the magnitude of the magnetic flux linkage is not very large, the change in magnetic flux linkage is very large. So therefore that's when you get your greatest EMF produced. Now remember, the current is always induced in the opposite direction due to Lenz's law. So as a result, the current starts as a negative. So when you look at your different options in your graph, the only one which starts off with the largest value at the negative is going to be D. The answer is D. Next question. A 500 turn coil of cross-sectional area 4.0 times 10 to the minus 3 meters squared is placed with its plane perpendicular to a magnetic field of flux density 7.5 times 10 to the minus 4 Teslas. What's the value of the flux linkage for this coil? So pause the video now, then unpause the video when you want to go through the answers. So, how would you answer this type of question? Well, we've always got to remember the equations involved. That magnetic flux linkage is equal to n phi, where that is BAN cos theta, which therefore, if you pop your numbers in, what's B? 7.5 times 10 to the minus 4. What is A? 4.0 times 10 to the minus 3. And what is going to be the value of N? Well, it's going to be 500 from the question. The angle is irrelevant because it's going to just be equal to 1. So therefore, we can ignore cos theta. We pop our numbers in and we get 1.5 times 10 to the minus 3 Weber turns, so our answer is going to be B. Next thing, we're going to look at some questions to do with nuclear physics. So let's look at our first question. A Geiger counter is used to measure the corrected count C from a gamma source in a vacuum. What is the relationship between C and the distance x between the Geiger counter and the source? So pause the video now, then unpause the video when you want to go through your answers. Right, so what would you do in this situation? Well, you've got to be aware that gamma source emission must follow the inverse square law, okay, due to the sphere of the radiation it produces, because we assume that a gamma source will produce radiation equally in all directions, and therefore it will expand outwards as a sphere. We know that it must follow the inverse square law because the surface area of a sphere is equal to 4 pi r squared. So this means the count rate is going to be inversely proportional to the distance squared. So C is inversely proportional to x squared. The answer is D. Next question. Protactinium has a half-life of 70 seconds. Which of the following is the time taken for 75% of the sample of protactinium to decay? So pause the video now, then unpause the video when you want to go through your answers. Right, so how would you tackle this question? Now, like the Capacitor's equation with exponential decay, we've got to do the same for radioactive decay. So the radioactive decay equation is A is equal to A0 e to the minus lambda t. Now again, the important detail is in the question. It tells you that 75% of the sample has decayed, so you've only got 25% left, or 0.25. So we can say A is equal to 0.25 A0, the activity at the start, is equal to A0 e to the minus lambda t, so we can therefore cancel the A0s through from both sides. So 0.25 equals e to the power minus lambda t, so therefore we can take the natural log of both sides, and then we can say log 0.25 is equal to minus lambda t. Now lambda is the decay constant, and you can work it out from the half-life. So the half-life is going to be log 2 over the decay constant, so decay constant is equal to log 2 over the half-life, so we can therefore say log 2 over 70 is equal to 0.0099, so pop all our numbers in, we get our answer to be, when we come out of the calculator, 140 seconds, so the answer is C. Next question. The initial activity of a radioactive source was 192 becquerels. The activity of the source is 24 becquerels after 12 days. What was the activity of the radioactive source after 4 days? So pause the video now, then unpause the video when you want to go through the answer. Right. So it's very important that you understand how many half-lives have taken place. So to decrease from 192 becquerels to 24 becquerels, there's been 3 half-lives, because we've just halved the value until we got to 24. So we did 192 halved, that value halved, we got to 24, so therefore there must be 3 half-lives. So if there are 12, there's 12 days and 3 half-lives, that means in 4 days there is 1 half-life. So when we do 192 after 1 half-life, so we divide it by 2, it's going to equal 96 becquerels. So that's our activity. So the answer is C. Next one, 207 Pb can be formed from a series of decays in beginning with 211 Pb. Only alpha particles and beta particles are emitted in the series. How many alpha particles and beta particles are emitted in this series? So pause the video now, then unpause the video when you want to go through the answer. Right, so you've got to be aware of how the nucleon number and the proton number changes with the emission of alpha and beta. So alpha decay causes the proton number to decrease by 2 and the nucleon number to decrease by 4, whilst beta decay causes the proton number to increase by 1 and the nucleon number is unchanged. Now, it's important to note that we know that the proton number is unchanged in this situation, even though it's not stated, because it's the same element, so it must have the same number of protons, but the nucleon number has decreased by 4. So therefore, we can have this take place with 1 alpha decay, but that has meant that the proton number has gone down by 2. But we know the proton number must stay the same, so therefore we need to have 2 beta decays take place to increase the proton number back up to the original value, whilst keeping that nucleon number still down by 4. So the answer is 1 alpha, 2 betas, the answer is B. So hopefully that brings us to an end in this revision session. So I hope that you found this useful and that we can now answer A-level physics examination style questions, we can assess our understanding on A-level physics, and finally understand what topics we need to improve on for AQA A-level physics. So thank you very, very much for watching this video on AQA A-level physics paper 1. Have a lovely day.